All right, hello, how's it going? My name is Alex Kuznicki, and I'm presenting our Streaming Wars Assignment 6 for the Software Architecture class at Georgia Tech. Online Master Science Computer Science. We are Group 86, and this is Fall 2020. The members comprised of Jonas, Jimao, Aaron, and Alex, and we worked together on this project. This project was aimed at coming up with 3 architectural changes to the original Streaming Wars assignment, which was originally a command line based application for collecting and displaying information between streaming services and studios which provided media events, as well as kept track of finances and financial transactions between demographic groups who were consuming these streaming events, as well as the transactions between studios and streaming providers who would license these events. So we made some architectural changes. Primarily, our changes were security, authentication, and authorization. So for security, we had our application connect to a SQLite database, which is basically just, it's a file format which works with a SQLite JDBC connection. And we encrypted that SQLite database using AES 256 encryption. And so our application is able to connect and read to this database using and unlocking that database using an encryption key. And only the user who has that encryption key is able to see that data that's in there. Additionally, we incorporated authentication into our application and authorization because we felt that if we're going for security, we might as well do a full secure application, which generally requires these other 2 components. So for authentication, we created some users in our system which can log in using a username and password. And these passwords are hashed for additional security in the database using the bcrypt algorithm. And this component was implemented using the Spring Boot framework, where we provided some configuration information to allow that to happen. On top of that, we also provided authorization. So in our application, we created a set of users, and we kind of scoped out what these users were allowed to do and which functions they're allowed to execute. For instance, as I'll show you, the admin can execute basically any function. The accountant can generally look at transactional information. Demographic group rep can look at the demographic group information and display commands, and etc. for the other roles that are there. We also implemented that using the Spring Boot framework, which I will also go over. So yeah, so I am done here with this, and I'd like to dive a little bit into an actual demo of our application that we built. Let me just make sure. Yeah, sounds good. So yeah, as this was a Java application, you can start our application very simply just by running this command, and I'll show you how that works. Great. So now our application is running, and I have how we interact with our application is we have exposed some endpoints through our application, which will connect through using REST API calls, and we submit these REST API calls to our application. And I have some example REST API calls that we've put together here, and Jonas was so kindly to develop this test scenarios test suite for us, which you are able to run the entire test suite on your own if you'd like. And these, not only are these tests example commands, but in each of the commands there is a test section which is an automated, it's basically an automated integration test which tests what is the expected response from running these commands. So for each one of these, there's an expected response. For instance, to truncate the tables in the database, only the admin has that privilege. So status code is 200, right? So that means okay. So let me just run that for you really quick. Okay, sounds good. So look, 200 okay, and we've got some information here. These are just debugging information for us as a developer to have access to. So let me show you what would happen if the demographic group rep tried to truncate all the tables. So that is forbidden. And so that's a little demo there on the authentication and authorization piece. And I kind of just want to show a little diagram of how that actually works. So initially, when the application starts off, before a user connects, there hasn't been any authentication that has happened. So initially, when a request is sent, right, Spring, before it starts up a servlet filter, which it accepts that information, and before it actually allows it to execute any functions, it intercepts that information and it does authentication. So in our API request, we pass in the username and the password, and Spring is able to parse that out, and it looks up in our database which users are there and what is their password, and it compares that information to determine if that user, based on their password, is who they say they are. On that next level, once we're authenticated, Spring actually will then check the authorization for that particular method, whether or not that user is able to execute that method. And so I can show you quickly here how that might be implemented, say for display service. We have annotated most of the methods, for instance, display demographic groups, and we have designated which roles in our system is allowed to execute these functions. And so we've done that for all the functions basically. And I have, in our documentation folder in our GitHub repo, you will find an Excel sheet like this, which displays for which of our commands that exists that were there and which commands that we also added for the new requirements. There's a corresponding mapping to which of the roles is able to execute those functions. So yeah, that's a little demo on how the authorization authentication works. And just to kind of show you how you can run through each of these test scenarios, you can click this button here, which will create a runner suite, which is basically just this. And I'm just going to rerun that for you now and show you basically through our integration tests that these tests are passing. So if you can see here that a lot of these requests, they expect, we were expecting like forbidden, or some of them were okay. And that again is the authorization piece here that I'm demoing, is for a lot of these roles and a lot of these commands that we are running, like offer pay-per-view or watch event. We've restricted these to specific users in the system. And just so to reiterate, after the authentication piece happens, we are performing the authorization here. And initially, how these users get placed into the system is we will deliver a database that is compatible with our application, and it has some default users in that system. Just to interrupt, so it looks like all our tests passed, great. Not only are we meeting our previous requirements and all the data is correct, but we've also successfully handled all the authentication and authorization, which we've planned to iterate. So yeah, again, back to where I was saying about the initialization of our application. We've also provided a user endpoint that basically only the admin is allowed to do for certain things. Actually, I won't say just the admin is allowed to do, but for certain requests, the admin is only allowed to do. So the admin themselves can add users and create users using this post command. So this will create a user by our user service here. And if I check where this is implemented, so we've designated that only the admin is allowed to create users. Also, the admin's the only person who's allowed to delete users. Users are allowed themselves to change their password, and that is done via this endpoint as well. We pass in a change password in a REST request, which looks like, let's see here, it's down here. So in a change password request, in the request body, you will pass in the username, the password, and the new password. And Spring will parse that, and it will take in that information, and the user will be allowed to change their own password. And so that is kind of tying into, as well as the security piece here, is we are delivering an application where the data is encrypted. It's got a set of default users in there. However, for additional security to separate out users and make sure that users don't have their own default passwords still set, we allow the users to change their own passwords. As well as the admin to allow a user to, or the admin will be allowed to create new users and then give that information to somebody. So say I want to create my own user, I will have to talk to the admin and say, hey, I want an account in this system. The user will give me username and password, great. And then when I go to log in, I can change my own password. And that way the admin themselves will not know my password. So that plays into the security piece here as well. So yeah, I've gone through that, demoed that for you. And I don't think I have anything else here for you. Oh, I would just like to show you that actually, so yeah, I will show you here really quick. So if I try to open our database, I'll try to grab our database here. It's going to ask me for the secure password here, basically the password that we use to encrypt the database. So there isn't a user here who's going to be able to view that data unless you have that secure password. If I just kind of stop our application, our database is here within the submission folder in our application. If I even just try to kind of peek at the database, it's unreadable completely. So that is definitely what we were looking for when we were trying to encrypt our database and provide additional security. Is we don't want, especially for transactional and monetary information, we don't want anyone to see that information who isn't designated to allowed to see that information. So that is our application and the demo of our application. And I hope you enjoyed this video, and I hope you enjoy playing around with it if you get the chance. Thank you.